Okay, and again, more of the mid-chapter 3 practice test. And I guess I had a kind of a glitch here when I went to the PDF because I think there was a space. At least there was a space on my original over here. See, there's a space there, so I don't know what happened. I took it off this one. Find the equations of the lines that are horizontal tangents. So draw a little line through there, so you can between horizontal and tangents. Sorry about that. Horizontal tangents to the curve y equals x cubed over 3 minus x squared over 2 minus 2x plus 1. So we want to find out where we have horizontal tangents. And the equations of the lines that are actually horizontal tangents. So remember, those are going to be horizontal lines, so the equation lines will be y equals. All right, so let's take a look at that. I'll do this over here so we have a little more room. So this is number 13. Oops, so you can see this, number 13. Okay, so I've got y equals x cubed over 3 minus x squared over 2 minus 2x plus 1. So we want to find out when we have horizontal tangents. That means the slope will be 0, so we want to find out when the slope is 0, so we have to take the derivative. So the derivative will be y prime. So that derivative equals 3x squared over 3 minus 2x over 2 minus 2. And these 3's cancel and those 2's cancel, so I have y prime ends up equaling x squared minus x minus 2. Now I can factor this, and I want to find out when that's going to be 0. So what values of x will that be 0? And then I put the x back in here, and I'll find out the y values, and those would be my horizontal tangents. So we can factor this, so this part won't be so bad. X and the signs are different. So large is negative, positive. Multiply to give 2, 2 and 1. That should do it. So when x equals 2, or when x equals negative 1, then my slope will be 0, and that's where I have horizontal tangents. Okay, now comes the hard part. I got to put these back in to the original function. So this is where it gets a little bit tricky as far as arithmetic is concerned. Okay, you will get partial credit if you get up here, but you got to do your arithmetic, and that does enter into. So let's try y of, and we'll try y of 2 first. So if I put 2 in here, I get 2 cubed over 3 minus 2 squared over 2 minus 2 times 2 plus 1. And that equals 8 thirds minus 4 halves minus 4 plus 1. Okay, and you work this out, arithmetically, however you would like to. And this is going to end up being, let's see how to do this. This was 8 thirds. Well, that's 2, so that's the same thing as 8 thirds minus 2 minus 4 plus 1. So that's negative 6 plus 1 was negative 5. So I kind of worked it out. I called this 2 and 2 thirds, 2 and 2 thirds, and this would minus 5. I have to let that ring, sorry, because I got to finish this for you guys, so they'll just have to call back. Okay? You probably got my message. Sorry about that. Okay, so this is what we've got. And how do I simplify this? This would be like, well, that's going to cancel, so that's just going to be 2 thirds. And 2 from 5 is negative 3. So that would end up being 1 third, so that would end up being 2 and 1 third. So that would end up being negative 2 and 1 third. So I kind of worked it out arithmetically, whatever is your pleasure. All right, so that's the actual value of the function. So my point where I have my of the horizontal tangency would be 2 and negative 2 and 1 third. And that's my x and that's my y. So my actual equation was y equals negative 2 and a third. Okay, y equals negative 2 and 1 third. Or you could also say y equals negative 7 thirds. Okay? So that would be one of them. And then we'll take y of negative 1, and we'll put this in. So we have negative 1 cubed over 3 minus negative 1 squared over 2 minus 2 times negative 1 plus 1. And we end up with, this isn't too bad, this is negative 1/3. That's going to be positive 1, so negative 1/2. Negative times negative is positive 2 plus 1. So that's going to be 3. So I've got, and this is going to be, I can put these in thirds, so this is going to be negative 2/6 and negative 3/6 plus 3, so that's going to be equal to negative 5/6 plus 3. So 3 minus 5/6 leaves me with 2 1/6. 2 1/6. So again, that point, oh, geez, I'm sorry you missed all this stuff. So here's my arithmetic. Sorry about this. So again, I put this in, and I got negative 1/3, a negative 1/2 plus 2 plus 1. Okay. And a negative, I made this 2/6 and 3/6, so that's negative 5/6 plus 3. So that's, or yeah, negative 5/6 plus 3. So 3 minus 5/6 is 2 1/6. Okay, 3 minus 5/6 is 2 1/6. I hope your fractions are good. They better be good. Okay. So my point would be negative 1. That would be my horizontal tangent point. Negative 1 and, or point of tangency, where the horizontal line would hit the curve. So that would be at negative 1 and at 2 1/6. So that's your x, that's your y. So your y, actual equation would be y equals 2 1/6, or you could write it as y equals 13/6. So those would be your horizontal tangent lines. All right? And if you want to check that, you could graph that and draw these lines in there. You could actually graph this in your calculator. I don't have time to do it right now, and you won't have a calculator for your test, but just so you want to see what's going on, graph this equation in y1, and in y2 put negative, and you could write negative parentheses 7 divided by 3. So I put negative 7 divided by 3 in y2, and you could put 13 divided by 6 in y3, and then you would see your horizontal tangent lines to the curve. All right? So that might give you a little bit more insight so you don't foul up when you see the problem. Okay? And I think I'll fit one more in here. This is number 14. And number 14, they just ask you to find, or you're asked to find, the average rate of change, good old average rate of change of the function over the interval 1, 4. All right? So we don't have to do any calculus on this. This is a pre-calculus problem. So we're over the interval 1, 4. So that's my average rate of change. Okay, so this will be over the interval AB. So that's going to be f of B minus f of A all over B minus A, and f of B, so I'm going to have to put this in. So here's my function, f of x equals x squared plus 3x plus 2. So my B will be 4, so what's f of 4? Let me see this over here. All right. So this is my function, so I'm going to look for f of 4 minus f of 1 all over 4 minus 1. So what's f of 4? So if I put 4 in here, that's 16. 4 squared is 16, plus 3 times 4 is 12, plus 2. So that's 16 plus 14 is 30, so that's going to be 30, minus f of 1. If I put 1 in here, I get 1 squared, plus 3, plus 2. So 1 plus 3 is 4, 5, 6, so that's going to be 30 minus 6. All over, and 4 minus 1 is 3. So 30 minus 6 is 24, all over 3, and that's going to be equal to 8. So that's your average rate of change. The problem was I forgot to zoom out from that other problem, excuse me. So that's why we had a little issue there, okay? even on the last one. So pardon me about that. Okay, so I forgot to zoom out. So that's how you find the average rate of change. Okay, so that's 14. And just in case you couldn't follow number 13, I'll show that to you again here in this picture. This, and there's number 13. And there we go. So we've got all this done here. So that's number 13. And this was all the arithmetic. So you can take a look at that good old fraction arithmetic. And you can follow that. Okay? Now, if you have any questions on these, just email me over the weekend. I'll try to check my email on Saturday. I'm going to be busy doing some other projects, but email me and I'll try to get to you and answer these. I hope that makes sense.